Okay, today's notes are on 11.4 conditional probability, and there's another handout to go with these notes. So the probability that an event B will occur, given that another event A has already occurred, is called conditional probability. Conditional probability would only exist when two events are dependent. Okay, so this is the new notation that you will see for this type of probability. How you would read that would be probability of B, that line we say given event A. So the probability of event B given event A. Our little calculation for any conditional probability. So I would find the probability of both, and I divide it by the probability of the event that is given. So it is always that second event listed in those parentheses. Okay, so we'll look at some examples here. A lot of your homework will have tables in your examples, so we're going to do a few of those first to start. This is copied from your book here, so a little multiple choice, but we'll calculate it. So our examples about Americans recycle increasing amounts through municipal waste collection. The table shows the data for 2007. We are being asked what is the probability that a sample of recycled waste is paper. And so it's explained the given condition is that the waste is recycled. A favorable outcome is that the recycled waste is paper. So when I set it up in this form, this would mean the probability of that we get paper given, so they told us the given condition is that it is recycled. Okay, so then I'm going to use my data in my table to calculate this. So according to our little formula on our last slide, we take the probability of both events over the probability of the second event that is given. So I'm going to find the probability that the paper is recycled. And that'll be over the probability that it is just recycled. Okay, it does not have to be paper. So we'll have a probability on top here. The probability that the paper is recycled, there are 45.2, and this is in millions of tons, but we can just leave it as 45.2. And that's got to be out of the total of everything. So if you add up the column for the amount of recycled, it'll give you 79.4. If you add up the column for not recycled, it'll give you 136.7 for a total of 216.1 millions of tons of waste altogether. So that will be in my denominator. So that's the probability for the two of them together. The denominator would be the probability that it's just recycled. So that would then be all of those. It doesn't just have to be paper, metal, glass, plastic can be recycled. So we have 79.4 out of the 216.1. Okay, so we have a fraction over a fraction, so it's a little ugly. But what you can do, we think back to some things that we've learned about dividing fractions. I could write 45.2 over 216.1 divided by, and what I'm dividing by is this fraction, so I will change that to multiplying by the reciprocal. So what's going to happen every time is that that denominator would cross out. Okay, so when I have the same denominator in both, I will always be able to cross those out. So your shortcut for your work, there's not a lot of work, that you would actually do for this problem would be just to put the number 45.2 that represents how many paper that is recycled, and that'll be over the number that represents the amount that is recycled. So basically what it's asking is, what would be the probability of all the recycled items that it would be paper? Okay, so that would be my fraction there. And this one asks to find it as a percent. So if you find that decimal about 0.57, so 57%. In this case, it asks for percent. Okay, now I wanted to show you how kind of the long way of going about this works with our little formula for calculating conditional probability. You can go ahead and jump to (45.2) over 79.4 right away. And that's really all I need to see for your work. Okay, so for our next example, another little table here. So researchers asked shampoo users whether they apply shampoo directly to the head or indirectly using a hand. What is the probability that a respondent applies shampoo directly to the head, given that the respondent is female? So the question that they ask, I wrote in this form. So probability that they plop shampoo onto their head, given that they are a female. We can take a look at that in the table. So I'm finding I'm finding both on top. So how many females put it directly onto their head would be 6. And then it is out of all of the females. So 6 of the 6 plus 24 would be 30 females in this little research study here. So that would come out to be 1/5 or 20% or 0.2 as a decimal. Okay. Now, they didn't ask me this in that question above, but I had it flipped because you will get a different answer. Okay, if I put female first, given that they've put it onto their head, there are still 6 females in our little study that drop it onto their head, but now what is given everybody who dumps shampoo on their head, which I don't know anybody, but apparently they exist. So 6 of the total would be 8. So of everybody who dumps on their head, how many would be female? 6 of those 8. Okay, and then I can divide each by 2. So 3/4 or 75% or 0.75 as a decimal, depending on what it asks you to, or how it asks you to write it. Okay. All right, here's our last 2 examples here. Another table situation. So probability they have experience given they have a diploma. So of all of these applicants who have a diploma, what's the likelihood they have experience? That is what that means. So of all the diplomas, because that's what it's out of, find all the diplomas, has high school diploma, yes, 54 plus 27, be 81 of the applicants. How many has experience with that diploma? Has experience is up here, yes is 54. So 54 of the people who have a diploma would represent that probability. If I'm simplifying that fraction, I can go ahead and divide both the top and bottom by 27. So 2/3 would be my answer, or 0.667 as a decimal. All right, last problem. This time I did not use a table, so hopefully it still makes sense. So probability of even given that it's shaded. So of all the shaded regions, how many are even? Is your probability here. So it'll be out of all the shaded because that's listed second. That's what's given that it's shaded. So I've got 1, 2, 3, 4 sections that are shaded. Of those, how many are even? 1, 2, 2 of the 4. So 1/2, 50%, or 0.5 as a decimal. Okay, that's our short little lesson on conditional probability. And this was your last homework and video. Congratulations.